So last time we were talking about um, equations of lines and how to find them, slope intercept form, point slope form, standard form of a line. We've also talked about how to find the equation of a line if I have 1 point and the slope. And what if I have 2 points? How do I be able to find the line between 2 points? You find the slope first and then use a point slope form. So we've been dealing with a lot of lines as of late. Um, this is lecture number 6. And today is the 22nd of February. Okay, now today we're gonna go further with this idea of lines, and we're gonna discuss first, particularly 2 sets of lines that we're really interested in. Um, the first of its kind are parallel lines. And the next set of lines are going to be perpendicular lines. So for those of you who've heard of parallel lines, what are parallel lines?
Lines that don't intersect.
Right. So lines do not intersect. Okay. What else do you know? So they never intersect. And how is it that two lines never intersect? What else can you tell me? Okay, so some people are already talking about same slope. So they have the same slope. And that's really the key here. That's really the key. They have the same slope or they have equal slopes. But what else can you tell me about parallel lines? So you have two parallel lines, right? So people tell me here, they never intersect. Okay, they never intersect. So they have the same slope. What else can you say? Well, we can say several things. We can say also that they point in the same direction. Point in the same direction, which would mean that they have the same slope, which would mean that they never intersect. So you see how all of these statements here are equivalent. They're the same thing. And a lot of times people overlook this. If you have two lines and they never intersect and they have the same slope because they point in the same direction, it must mean that the distance between the two lines is the same throughout. So the distance between the lines are the same. Are the same throughout. So if I draw a line that's perpendicular, we'll talk about that. And I want to find the distance. It's always going to be the same. This length here will be the same as this length here. It's the same. And it's the same throughout. Just like on a road, right? On a road, most of the time those lines are parallel and they don't intersect, and the distance between those two lines, those two lanes, right, creating lanes, are the same. But in particular, what we're going to be interested in is this idea of the same slope. So parallel lines have the same slope. Okay, that's one set of lines. And the second set of lines are called perpendicular lines. So what are perpendicular lines? What are perpendicular lines? Okay, they do intersect. So that's a true statement. But just because they intersect does not mean that they are perpendicular. So there's something more about just being intersecting lines. They intersect in a very special way. Yeah, that's right, Emil. They form right angles. So they are perpendicular. The word perpendicular is um, implying right angles. So they form right angles. at point of intersection. So if I draw two lines, like an X here, and they form a right angle, then form a right line. They form perpendicular lines. What else do you know about perpendicular lines? So not only do they form right angles, there's something about their slope. Does anybody remember? What about their slopes? They do have different slopes, but they're a very particular kind of different slopes. Like there are different, but there's a certain relationship between slopes of perpendicular lines. Yes, that's right, Elizabeth. They're opposite reciprocals. We also call them negative reciprocals. So the slopes are negative or opposite reciprocals of one another. Example, let's say my slope here is a negative 3/4. Then the slope for this guy would be the negative reciprocal. The negative of a negative is a positive, and the reciprocal just means you flip the fraction. So then the slope here would be 4/3. That's what it means. That's what it means to be negative reciprocals. Negative reciprocals. Okay. And the one thing associated with the slopes is that the product of slopes equals -1. And why is that? It's because the slopes are negative or opposite reciprocals of one another. If you take -3/4, for example, and multiply it to 4/3, the result will be -1. So whenever you have perpendicular lines, the slopes, when they multiply them, will always equal -1 because they are negative reciprocals. And this is going to be the key statement here for perpendicular lines. So just as in parallel lines, you have the same slope. In perpendicular lines, we care about the fact that their slopes are negative reciprocals. So boom. Okay, so those are the main things here. Okay. Now we're going to be interested in finding the equations of these lines. So we're going to be finding equations of parallel lines. So an example of that is find an equation of a line that passes, sometimes they say contains the point P, and this point P has the coordinates 2, 3, and so not only that, and is parallel. Keyword here is parallel. Is parallel to the graph y equals 1/2 x minus 4. So I want to find the equation of a line that contains the points 2, 3 and is parallel to the graph of y equals 1/2 x minus 4. So I'm trying to find, what's the goal here? What's my goal? I want to find y equals mx plus b. That's my goal. So what do I need? I need an m and I need a b. Same thing with every other problem with equations of lines. I'm always looking for the slope and I'm looking for the y-intercept. So then how would I figure out my slope? So the first thing is find slope. How do you figure out the slope of a line that is parallel? So how do I figure out the slope? So find slope for the parallel line. Keyword, parallel. So then what can I say? That's right. You have one set of coordinates for the point. So we're going to use that point, but we're not going to use that yet. I want to find the slope first. What information here can I use to find slope? Find one set of coordinate points for the given equation. The thing is, Emil, I don't have a given equation for what I'm looking for. I have a given equation for the line that is parallel to the line I'm looking for. Do you see the difference? So this line, right, y equals 1/2 x minus 4 is not what I'm looking for. I'm looking for the line that happens to be parallel to this line that also contains this point. And that is the key, Adriana. Good. The key here is that since it's parallel, so yes, the slope is 1/2. That's right. That's the logical observation we make. We have to make this observation ourselves. We have to say, oh, it's parallel. Because the lines are parallel, the slopes must be the same. So because the lines are parallel, for the parallel, I should write the parallel line, then the slope equals 1/2. Look how quick that was. Easy. I know the slope is 1/2. It must be because the lines are parallel. So step 2. What's step 2? Then I think now, Emil, we can use what you suggested. We have one of the points, right? Don't we have a point? The point is what? 2, 3. And then what else do we have? Slope. The slope is 1/2. So then what do you think we're going to use? We got point, we got slope. So we use what? We use our handy dandy what?
Calculator.
Sure, we can use our calculator, but what I'm looking for is what Tyler just suggested in the chat box. It's the point slope form. We got the point, we got the slope, point slope. Like that's how simple it is. Point slope, point slope. Point slope form, use point slope form. That's it. That's it. So it'll be y minus y1 equals m times x minus x1. What's y1? Y minus 3. What's m? 1/2. What's x minus 2? I'm done. I got what's called the point slope form. I got it. So I'm done with finding the equation of the line. This is the equation of a line in what? Point slope form. If I wanted a slope intercept form, then what must I do? I must do a little bit more algebra, right? I must distribute the 1/2, and then I must solve for y. So if I do that, I do y minus 3 equals 1/2 x minus 1. I distribute the 1/2. And then I add by 3. And I get y is equal to 1/2 x plus 2. Done. So this here is the slope intercept form. Okay? Can we use either form? Of course, they're the same. It's just that maybe in the homework, in the web assignment, they might be more specific and saying, hey, find the equation of the line in slope-intercept form. So you should be able to know, you should be able to do either or. You should be able to find the point slope form or find the slope-intercept form. It should be either or. But what do you put on the test, for example? That's going to be, unless I specifically say, hey, find the point slope form, then use the point slope form. Find slope-intercept form. So there's going to be specificity as to which form to use, but you should be able to do both. Okay. And so then what is this? What is this? This is the line. This is the equation of the line that passes the point 2, 3 and is parallel to the graph y equals 1/2 x minus 4. That is what this line is. And we did it. What do you guys think? Not too bad, right? I hope not. I hope it's not too bad. Okay, so that's one thing. Now let's say I have the same kind of question, right? So I want to find an equation of a line that goes through the point -1, 4 and is parallel to the graph of 2x minus 3y equals 5. Okay. Now, if you notice, the way the wording is of both examples are very similar. They're nearly identical. The only difference is the point here, right? They call this point. The point, I still have a point, but the equation of the line that I'm considering is not written in slope-intercept form. It's written in standard form. But what am I going to do? I still want to find slope first. And I still have a parallel line. So the slopes are what? The same. Now the question is, what is the slope? Now you see how in the previous example, I was able to find the slope almost immediately because it was in slope-intercept form. 1/2 is the slope. The problem is, this slope here is not immediately seen. So then what am I supposed to do on my end? How do I find the slope of the line 2x minus 3y equals 5? Isolate y. That's right. I want to change it. I want to change it to slope-intercept form. So then change this to slope-intercept form. So this would be 2x minus 3y equals 5. Minus 2x minus 2x minus 3y equals negative 2x plus 5. Divide by -3, divide by -3, divide by -3. What do I get? I get y is equal to positive 2/3 x minus 5/3. Now what? 2/3 is my slope. Two-thirds. That's my slope. Do you guys see that? My slope is 2/3. Good. So I found my slope. And now what I want to find is the equation of the line that has a slope of 2/3 and has a point. So the point here is what? -1, 4. So it's -1, 4. That's my point. I just found out that my slope is 2/3. So then what do I have to use? Use point slope form. So it's going to be what? Y minus y1 equals m times x minus x1. Y minus y1 is y minus 4 is equal to 2/3 x minus -1. So y minus 4 is equal to 2/3 x plus 1. Distribute the 2/3, I get y minus 4 equals 2/3 x plus 2/3, right? Because I distribute. And I'm going to add by 4, and I'm going to add by 4. And I get that y is equal to 2/3 x plus, and then 2/3 plus 4. (14/3). Let's see. So 2/3 plus 4, it's really over 1, right? Multiply by 3/3, and I get 2/3 plus 12/3, and that equals 14/3. So you're right. You're right, Emil. 14/3. And this is the line. Again, I could have finished here. I could have finished here if I wanted just the point slope form. And then this here is the slope intercept form. Are we all okay? Does this make sense? Finding the slope, finding the equation of a line that's parallel to other lines. So I have a line that I'm trying to find that's parallel to the line that I'm given. So I have to figure out what the slope is. Once I have the slope, I have the point, use point slope form, and I'm done. Okay, so that's what we do with parallel lines. Now we're going to do the same exact kind of thing in terms of finding the equations, but now we're going to find the equations of not parallel lines, but finding equations of perpendicular lines. Yes, of course. I can go back up. Yeah, just let me know if you guys need some time just to write this down. Alrighty. Okay, so we're ready for perpendicular lines. So with perpendicular lines, it's not going to be as straightforward as parallel lines. With perpendicular lines, you have to do one extra little step. And in particular, is going to be the slope step, because we have to figure out the negative reciprocal. It's not going to be the same. All right. Yep. Switcheroos, right. So now, so the example, find the equation of a line that contains P negative 2 comma 1 and is perpendicular to the graph of y equals negative 2/3 x plus 2. So the name of the game hasn't changed. I still want to find the equation of the line. I still want to find the slope. That's the first thing, right? Find slope. However, I can't just say, hey, the slope is negative 2/3. Why not? Because it's perpendicular. So my slope of the original line that I'm considering is negative 2/3. So then what's going to be the slope of the line that I'm interested in? That's perpendicular. So what's the perpendicular line slope? It can't be negative 2/3. It has to be positive 3/2. That's right. So the slope is positive 3/2. So that's all. That's really that's all the major differences. Now we have to find the negative reciprocal, and then once I have that, I got the point again. I got the point. It's negative 2 comma 1, and now I have my slope. My slope is 3/2. So I got the point. I got the slope. Use point slope. So now I got point slope will be what? Y minus y1 equals m times x minus x1. Y minus y1, okay, again, y1 comes from the point, and x1 comes from the point. So this would be y minus 1 equals 3/2 parentheses x minus parentheses negative 2. Minus a negative, this would be a positive. So this would be x plus 2 parentheses 3/2 equals y minus 1. So I am done if we consider just finding the point slope form of a line. If I want to write the slope intercept form of a line, then I must distribute, and I get y minus 1 is equal to 3/2 x plus 3/2 times 2 is 3. Add by 1, add by 1. And I get y is equal to 3/2 x plus 4. So this here again, point slope. And this here is slope intercept. Okay, so we made that one extra step, which was to flip and to negate the original slope to find the slope of the intersect of the parallel line. Not parallel line, perpendicular line. So any questions about this? Okay, I'm glad everything is making sense. Okay, so if we're good with this, let's look at another example, and this time it's going to be similar to the second example of for parallel lines. We're going to have a equation of a line that is in standard form instead of slope intercept form. So if I want to find the equation of a line that contains point -2, -4, and is perpendicular it's perpendicular to pardon me, 2x. No, let me use another one. Yeah. 3x minus 5y equal to 2. So now I want to find the equation of a line that contains the point -2, -4, but is perpendicular. It's perpendicular to 3x minus 5y equal to 2. The first thing I want to find is the slope. That doesn't change. The problem with this one is I don't have the slope of the line immediately. I can't just get it immediately, 3x minus 5y. So what do I have to do instead? How do I find the slope for 3x minus 5y equal to 2? It's very similar to what we did with the previous scenario with parallel lines. So how do I figure out the slope for 3x minus 5y equal to 2? We have to isolate y again, right? Get y by itself. So we got 3x minus 5y equal to 2. Subtract 3x, subtract 3x. I get negative 5y equals negative 3x plus 2. Divide by negative 5, divide by negative 5, divide by negative 5. And I get that y is equal to 3/5 x minus 2/5. So then immediately, what do I find? I find that my slope is 3/5. However, this must be perpendicular. So if it's perpendicular, what's going to be the slope of the perpendicular line? It's not going to be 3/5. It's going to be what instead? It's going to be the negative reciprocal. That's right, Adriana. So it's going to be negative 5/3. So it's a negative reciprocal. Okay. So once I have that, then I have, what do I have? I got the point. What's the point? -2 comma -4. And then what's the slope? -5/3. Point slope form. So it's going to be y minus y1 equals m times x minus x1. So it's going to be y minus -4 equals -5/3 x minus -2. Y minus -4 is y plus 4 equals -5/3 x plus 2. So it's y plus 4 equals -5/3 x. And remember, we have to distribute. So this will be -10/3. Get y by itself. Subtract by 4. Subtract by 4. So get that y is equal to -5/3 x. -10/3 minus 4/1. Multiply this by 3. -10/3 minus 12/3. And I get -22/3. So this is -5/3 x minus 22/3. So that's that. And that's that here. This is the point slope form. And this is the slope intercept form. Okay. Any questions about finding the equations of parallel lines, finding the equations of perpendicular lines? I hope it's clear. clear as day. Any questions? On a quiz, would it ask for which form? Of course. Oh, yeah. Yeah, on a quiz or on an exam, I would specify I would most likely not specify what form you should have. And that's my dog. I don't know if you guys hear it. Yeah. So it shouldn't be, yeah. Why did you times 4 by 3 over 3? Oh, because I want to have the same denominators. Because I want to subtract two fractions with the same denominator, so I must make them the same. So that's how we usually subtract or add fractions. We make the same denominator, 3 and 1. The least common denominator would be 3. So make the 4, multiply that by 3, and multiply the 1 by 3, so you can have the same denominator, 12 over 3. And unfortunately, no, David, you can't see it. It's in a different floor. But anyways, clear? How did you get 14 in the previous section? Which section? Are you talking about this one here? Fiona? Yeah. So it's the same idea, right? We distributed the 2/3. So 2/3, ends up over here on the right as well as in front of the x. I want to get y by itself, so we add by 4. And then we're just adding 2/3 plus 4 again with this kind of same denominator business, right? So we make them the same by multiplying by 3 over 3 on both sides, on numerator and denominator. So then this 4 becomes 12 over 3. 2/3 plus 12/3 becomes 14 over 3. So remember, adding, subtracting, multiplying, dividing fractions is a very essential skill, particularly with algebra. You need to know and feel comfortable with adding, subtracting, multiplying, dividing fractions. Okay? Okay. So yeah, so we've been going nonstop so far on linear functions, lines. We know how to graph lines. We know how to write it in different forms: point slope form, standard form, slope intercept form. We know how to find the equations of those lines. If I have a point and a slope using point slope form, I can find the equation of a line. If I have 2 points, find the slope and then use point slope form. Now I can find equations of lines that are parallel to other lines through a given point. Now I can find the equations of the lines given a point and another line that's perpendicular to it. So I'm having all these different different aspects of linear functions that I'm able to apply. And then I guess maybe to some, you might be like, okay, we get it. Like, we've talked about lines all the time. Why do we care so much? Why do we care so much about lines? Isn't there a cooler curve to talk about? Like, can't we just go straight into quadratics? Can't we just talk about even more interesting things? Well, the thing is that lines are so, like, more than just like it's a very simple graph, right? It's just a straight line. It's just draw a ruler on it and then boom, you have a straight line. Actually, lines are very, very such a basic graph, yet it's extremely powerful. Without getting too deep into it, what we're gonna do next is probably one of my favorite. It's one of my favorite aspects of mathematics. What you're gonna learn is a very rudimentary version of what it is I'm really talking about. So what I'm talking about is what's called linear algebra. And for those of you who are maybe interested in being math majors, or those of you who are interested in doing computer science, you're gonna see that class eventually, especially at the college level. And I think it's a remarkable subject. And the reason why I say this is not just because of the math part of it. It's just it's become so useful in our daily lives. Even you may not know it, may not see it personally, but a lot of the stuff that we deal with, especially when we talk about technology, linear algebra is embedded in nearly every facet. And I'm talking about almost everything, like everything you guys use, YouTube, Google, like without linear algebra, Google would not exist. If you understand how Google actually works on the back end, um, linear algebra is in it. Like there's something called the Google, I think it's called the page rank algorithm, which is the fundamental idea of how Google even ranks the pages when you search something up, and it utilizes linear algebra. But like I said, without getting super deep into it, what we're going to learn is a very much more contained version of what I'm discussing. So what about these lines, right? What we're going to care about is we're going to care about having what happens when we have two lines on a graph, and what happens to when we have two lines, and how do we figure out that point of intersection and what that point of intersection actually means. So that's what we're going to be doing. We're going to be what's called solving a system. Probably heard this word already. System of equations. Solving systems of linear equations. Pardon me for like that whole tangent there, because I can go kind of a different dimension really when we talk about this stuff. But solving systems of linear equations, and we're going to do this by the first method. So our first method using or by graphing, I should say. And there's two other methods that we're going to learn. So one of them right now, we're going to learn about the graphing method. Then we're going to talk about substitution method. And then lastly, the elimination or the addition method. So before we get into that though, what do you guys know about what would happen if you have two lines on a graph? Can anyone tell me all the possible scenarios? So if you have two lines on a graph, what could occur? So these are like the three possible scenarios with two lines on a graph. So scenario one. So yes, so Fiona, Maria, right. So you have a scenario, which is pretty much what you would expect when you have two lines, right? You can have two lines and all of a sudden they intersect at one particular point. Boom. That's one particular point. So so we call this system, so we have one point of intersection. When we have one point of intersection, we're going to say the following. We say that we have one solution to the system. So this system has one solution because of the one point of intersection. So this point of intersection is the solution. Whatever that point is, that point has the x and y values that represent the solution for the system. And the name of the system is called an independent. This is called an independent system. Okay, so that's kind of like the obvious one. That's the one that we expect. Now, remember, I said there's three though. So we have a possibility that the two lines do intersect and they only do one time. And that system is called the independent system, or independent system of equations. Okay, that's number one. What other possibility could occur? What do you guys think? They never intersect. Of course. We just talked about it, didn't we? We talked about lines that never intersect. Those two lines are what? These two lines are what? Lines that never intersect are called? So these are zero. There's 0 points of intersection. The lines are what? Lines are?
Parallel.
Parallel. If you have 0 points of intersection, how many solutions do you have? Zero. So there's no solution. There's no solution to the system for the system. And what we call this system is, we call it inconsistent. So when we have two lines that are parallel, then the system of those two equations have no solution since there's no point of intersection, and we call it an inconsistent system. Great. So we talked about two scenarios so far. One scenario, only 1 point of intersection, obviously. The second scenario, no points of intersection, parallel lines. What's the third? Does anybody know a third? This is the strange one. I think it's strange, but it's interesting to think about. Absolute value, not exactly. Infinite solution. Whoa, infinite. 2 points. So first of all, okay, so very good. Let's bring this up. Somebody said, hey, there's an infinite number of solutions, and someone says there's 2 points of intersection. So what is it? Is it possible for two lines to intersect at 2 points? Well, if you could, but if you do a if you make it into a parabola, then yes, but then a parabola is not a line. So my question is, can I create two lines where they intersect 2 times? No, I can't. But the interesting thing is I can make two lines intersect an infinite number of times. So then you're like, right. So the idea is this. The idea is that if I have a straight line, so this is when you kind of have to like make believe a bit. You have to like imagine yourself. If I have a straight line, right? And I have the same line drawn again. Maybe that's not the greatest color. But if I have a straight line on top of it, then there's an infinite number of points. So this is a very strange, but this occurs. This is when you have an infinite number of intersections. There's an infinite number of them. And because of that, there's an infinite number. There's infinitely many solutions. There's infinitely many of them. And we call this a dependent system. Okay. So we have three systems. Independent, one solution, 1 point of intersection. Inconsistent system, 0 points of intersection. No solution, parallel lines. And then we have this very strange case when we have a line on top of itself, which means that they're the same line. They're the same line. Two of the same lines. I know it's kind of weird. It's redundant, but this can occur. That's the whole point. It could occur that you have two equations of two lines and there happen to be the same one. That redundancy causes an infinitely many number of solutions to exist. And it's called a dependent system. So good. So these are the three possibilities when we talk about systems of equations. Two lines on the same graph. And these are the only three. There's no other scenario that occurs. These are the only three. Okay. So now I want to solve by graphing. So look. So now how do we set the system? So what's the system going to look like? System of linear equations. It's literally just writing two equations that are lines, one after the other. So usually we write it this way. We say 2x minus y equals 3. And then we got 4x minus 2y equals, 2x minus y, and then 3x plus y equals 2. So this is my system, guys. This is it. 2x minus y equals 3, one equation, one standard form of a line, and 3x plus y equals 2, second equation, second standard form of a line. And now is how do I solve this? I want to solve. So I want to solve by graphing. So I'm gonna use a graphing paper for this. You know what? Let's use, where is it? Square paper, there we go. So I'm gonna graph this, right? So boom, boom. Okay. So I got the y-axis and I got the x-axis. And I'm gonna graph each of these lines. So my first graph is 2x minus y equals 3. Now, how am I gonna write this? How am I gonna graph this? What do you think I should do? Should I keep it in this form or should I do something to help me out? That's right. Very good, Emil. So I want to get y by itself, right? So I subtract 2x on both sides. And I get that negative y equals negative 2x plus 3. Divide by negative 1, divide by negative 1, divide by negative 1. And I get that y is equal to positive 2x minus 3. So then I have a lot of information here, right? I got the slope intercept. So I know that this is going to be 1, 2, 3. So negative 3. Then I'm going to use a different color for this. So then this is my starting position. And then I'm going to do what? I'm going to move up by 2 because of my slope. So this is my slope. This is my slope intercept form. So my y-intercept. So then I go up by 2 over 1. My next point, right? I go up by 2 over 1, up by 2 over 1, and so on and so forth. And then what can I do? I have a straight line. I can use a ruler if you need, right? And then boom, I got the equation. I got the graph. So this graph is y equals 2x minus 3. Done.
I'm sorry, can you explain that again? The graph, the line that you make?
Yeah. So in my previous lectures on graphing lines, right? I'm graphing this line here, y equals 2x minus 3. And how do I do that? I first utilize the slope-intercept form, which is what this is, 2x minus 3. Now, what does the b tell me? B tells me the y coordinate for the y-intercept. So the y-intercept is -3. And remember, -3, the y-intercept indicates where I start, where I would suggest to start. I start here, so then I draw a little dot right there, boom. How do I get the rest of the dots, though? Well, I have to use my slope. My slope tells me what? My slope is the rise over run. It's saying that this is 2, or in other words, it's 2 over 1, which means is that the number on the top tells me how many boxes I go up, and the number on the bottom tells me how many times I move to the right. So from here, I move up 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, and then so on and so forth. It keeps on going. This repeats every single time. This repeats every single time. Does that make sense? It's like a little, you can think of this like a little staircase, and the staircase is the same throughout for infinitely, and also going downward, right? Going down, you also go. It's the same staircase again and again. So you can think of it as a staircase, and we just calculate the slope. So that's the equation for one of them, correct? That's only one of them. And what's the other one? 3x plus y equals 2. That's the other one. And we'll do the same exact thing. Solve for y. So subtract by 3x, subtract by 3x, and I get that y is equal to -3x plus 2. So again, I got my slope-intercept form, -3x plus 2. Now what? Now I'm going to be moving up by 2. I'm going to start at 2 now. I'm going to use a different color. So at 2. And then what does it tell me? It tells me this is my slope-intercept, my y-intercept, and this is my slope. My slope is -3. So what am I going to do from this point? I'm going to move down by 3 and move over to the right by 1. So I go 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And I continue doing this, so on and so forth. And then, let's see if I can get this line through these points. And then boom, I got y equals -3x plus 2. So look what I just did. I graphed both of the lines. Now what? Why do I care about these two lines? What do I care about these two lines? I care about what? I care that they intersect. Exactly. The intersection point is what we care about. So then they intersect. And what is the point of intersection? This is one point of intersection. So then what is it? The coordinates are going to be what?
I believe -1.
That's correct. You're correct. 1, -1. That's my solution, guys. I did it. I solved it. I solved the system. So my solution is the coordinates 1, -1. Or you can write it as x equals 1, y equals -1. That's my solution. I did it. Now, I want to ask you, what does it mean to solve a system? So it's more than just finding where they intersect. That is that's part of it. That's one half of it, I would say. So half of the whole point of solving is to find the point where they intersect. But what's the other half? How else would you describe a solution? It's not only the point of intersection. So we have to understand the algebraic reason for why it's called a solution. Why is it called a solution? But why? Why is 1 comma negative 1 a solution to the system? Well, the first reason is it represents the intersection point of the two graphs, of the two lines, the intersection point of the two graphs, two lines. And the other reason why is because they both, the values, the x and y values, and you hear this word before, satisfy both equations. You can use the word simultaneously. Sometimes they call it simultaneous equations because you want to solve for the value of x and y that solve both of them, not just one. Now, what does that mean algebraically? That means that, look, I have the first equation, right? 2x minus y, 2x minus y equals 3. And then what do you think I'm going to do? Plug in. So basically, I'm checking if this is true. Check. So the first equation is 2 minus negative 1 equal to 3. Well, definitely 2 plus 1 equals 3. So yes, indeed, that worked. How about the second equation? Second equation is 3x plus y equal to 2. If I plug in the values, does this give me 2? Sorry, this is 3. Well, 3 times 1 is 3. 3 plus negative 1 is 3 minus 1. That equals 2? Check. So they both work. And that's the thing, guys. That's the only point that works for both of the equations. No other point does that. That's why there's only one point of intersection and there's only one solution. Do we agree or disagree, or is this clear? So do you understand that we're just applying what we already have been doing, which is graphing lines? Now we're just graphing two of them. And after we graph two of them, what do? Find the point of intersection, if there is any.
Wait, Professor, I have a question.
Yes.
The part where it says over there, like where you were checking, like with 2x minus y equals 3 and whatever.
Yeah.
What do you like? Why do you have to like check? Like, what do you mean by that? Like, what exactly are you checking?
Thank you, Emil. It's exactly what I am saying. It's exactly the checking is answering the question, why is 1 comma negative 1 a solution to the system? So one reason, that's why I put the 1, right? One reason for why it is a solution to the system is because it is the point of intersection between the two lines. So that's one reason. But that's not the only reason. Or I should say, that's not the full picture. That's half of it. The other half is these coordinates, 1 comma negative 1, represent the x and y values that make the equation, both equations, true. When you say satisfy, it means make it true. Make true. Like, for example, when you solve an equation, right? forget about this for now. When you solve an equation like this, right? Like 5x plus 2 equals 7. What do? We subtract by 2, then 5x equals 5, and then you say x equals 1, right? If you really want to be thorough, you would say, hey, let me check. So you'll be 5 times 1 plus 2. Does this give me 7? Well, obviously, right? 5 plus 2 equals 7. Check. That works. I know it sounds like, wait, what's the point of that? It's just to demonstrate. It's to demonstrate that these are indeed the x and y values that not only make my first equation true, this is true, right? This is a true statement. But also my second equation is also true. Those x and y values make both of those equations true. And henceforth, ergo, it's a solution. What I'm trying to demonstrate to you is that there's more than one way to visualize or understand this concept of solution. It's graphical. Number one is a graphical reason. This is a graphical reason. So you say, hey, yeah, it's the solution because they intersect at that point. The second reason is a algebraic reason, because it's algebraically making both of them true. So then what we're going to end up doing is solving this system of equations without graphing it. So the two other methods that we're going to learn, which are substitution method and the elimination method or the addition method, those two methods will never require you to graph them. The point is that you should understand that the solution that you get has a double meaning. It's a point on the graph where they intersect, and at the same time, they're the x and y values that algebraically make everything work. So I'm trying to give you the full panoramic view as to what are we doing here. And I know it takes some time to understand why is it that we even care about these different reasons. The whole point is, guys, I don't want to we only have like a few minutes left. But the thing is that this kind of problem, right, where you have, you start to see that you have two lines, right? And you have two variables. So you have two equations and two unknowns, correct? And we solved it. We solved the system by graphing. Now somebody may think, hey, what about 3 equations and 3 unknowns? Can we do that? And the answer to that question is, of course. And then you're like, huh, let's not stop there. Let's do 10 equations with 10 unknowns. Is that possible? And the answer is, of course. And then, is there a limit to this? Can we do 100 equations with 100 unknowns? And the answer to that is also, yes, we can. Can we do 1,000 and so on and so forth, right? And the answer to that is yes. And that's where linear algebra is born. And in that question of how big can this system get? It can be as big as you'd like. It could be 1,000,000 by 1,000,000. And then we can talk about that another time. But what I'm saying is that this is like the origin of this. Like this kind of problem has been solved for thousands of years. Like people have been studying this, have studied this thousands of years. How to solve a system of equations, just as simple as this: 2 equations, 2 unknowns. And then we start to grow from this. But anyways, for those of you who are interested in the continuation of this, you would have to go to Math 231, which is linear algebra. It's a worthwhile class to take. But anyways, is this clear now? Do we understand what are we doing here? What are we solving for? What does that point of intersection represent? Like, what does it mean algebraically? What does it mean graphically? So once we have that understanding, then everything else as we continue on with this is going to have more meaning and it will provide us with more insight. Okay. Like I said, this is like one of my favorite stuff to think about. Hopefully it will pique your interest as well. All right, so homework is due tonight.